I think that's my number one thing is that we've got to make these projects fun.
Yep.
Whether your idea of fun is like a steep learning curve like mine is like kind of a sick concept of what fun is.
Mhm.
But we've got to have that engagement, you know, we've got to have some reason why people are coming to do the thing that's a little bit harder, you know, when it's our first time. So
Yeah.
yeah, let's have some fun while we're delivering passive houses. And then the
Yeah.
whole rest of everybody will jump in.
Hello, and welcome to the Reimagine Edit, a special series of the Passive House podcast that shares curated insights from the conversations happening in the Reimagine Buildings Collective, our membership community where we bring together climate-conscious builders, designers, and changemakers to share lessons, level up our work, and build the networks we need to thrive. In this episode 14, we'll hear from Beth Campbell, Ryan Abendroth, Mike Fowler, Kevin Brennan, Kara Haggerty Wilson, Nakita Reed, and Michael Ingui. I'm Zack Semke, Director of Passive House Accelerator and host of the Reimagine Buildings Collective, and thanks for joining me. Our first clip is a question from Mike, a member of the Reimagine Buildings Collective, of Ryan Abendroth, an expert in residence in the collective. Ryan is the former certification manager at FIAS and founder and principal of Passive Energy Designs. Here, Mike asks Ryan about how to manage the very high humidity in places like Houston.
One of the things, putting the Zender system in, I keep wondering how to deal with the really high humidity come in Houston, Texas. And a good percentage of the summer during the day, you're looking at 70, 80, 90% humidity. And so you're sucking in that high humidity and you're blowing out the dry air from the inside the house. So, it's transferring some of that humidity is getting brought back into the house. I don't know numbers wise as to how much is I don't I guess there's no way around it. If you want to ventilate, you just gotta put up with the high humidity air coming in.
Yeah, so a couple notes. One, my business partner that I founded Build Zero with lives in Houston. So we do have some, firsthand experience of like that sort of climate. In most of our residential projects there, I feel like we are just saying, it's okay. Like we're gonna do that ventilation just like we would maybe anywhere else for the most part. And have then for sure a dedicated dehumidification system that is going to be dehumidifying that space or that house, but it doesn't need to be necessarily connected to one another. I think this is the question. I've done some other projects with some engineers, like the first commercial passive house. I think it was actually the first non-residential passive house.
Mm.
Was in Kansas in 2012, and it was about 1,200-ish square feet, but it was a classroom. And it also had a glass facade on the south with a trom wall and like a little bit of Western glass too. It had a big overhang. But so there was a lot of solar gain. And then I put into Woofy like, like four people or something. It's like a little office thing. But it was actually a classroom. And so according to the code, the occupancy was 44 people. And if you put the humidity load, even of Kansas, into that building, plus the, glass wall facade, plus 44 people in a 1,200 square foot building, the
Wow.
engineer designed this thing to have three, ducted mini splits in it, like all like 18,000 or something BTUs per hour, where Woofy's telling you, or, PHP, I think back then, that it's like 5,000, BTUs or something per hour. But when you add the 44 people in, of course, it goes way up. I bring this story up because that project, the engineer did not feel comfortable putting the amount of ventilation air for 44 people into that space without dehumidifying it. So the ERV in that project runs into the back of the air handler and uses the air handler for distribution, so that it can do, some dehumidification and things. I don't know that you need to go to that route because at the normal residential occupancy, I think you can just dump ventilation air into a room and then that gets picked up by your mechanical system, which should include kind of a whole home dehumidifier. And I don't know that you need to precondition it, if that makes sense.
Yeah, it's going to be a pair of Series 7 water furnaces, which
Mhm.
can ramp way down and pull a lot of humidity
Yeah.
out, I think.
So you
Uh,
probably are you using that for distribution? Like you're running your ventilation into that air handler, into that duct system?
wasn't planning that the initial plan was just traditional Zender
Yeah.
layout, with a individual locations in each different rooms
Yeah.
for intake and exhaust. But
And so generally, I do think that's like the best way to go about it because if you run it into the air handler, according to like the, FIAS guidelines, you also need to run the air handler at minimum speed all the time. And that fan energy is also not great in a really hot climate.
right,
And so you generally would want to avoid that. However, I have a project that I worked on here in St. Louis that is geothermal and has a Zender and has a like Ultra Air or Santa Fe dehumidifier on it. And they are all running through the same duct system. And they're running that air handler all the time to make sure that they're getting that distribution throughout the whole building. I don't know that that's optimal, but that house still performs extremely well.
Next up, Michael Ingui, founder of Passive House Accelerator, and Mike Fowler, sustainability integration leader at Methune, discuss the passive survivability of buildings, particularly during heat waves. Mike draws on an example that hits close to home, quite literally, and that he's talking about extremes in our shared hometown of Seattle.
You'd,
Yeah.
you'd rather survive and be uncomfortable rather
Mhm.
than the alternative.
Yeah, and I think for me, the question really also becomes, does it really even make sense to design for even more than that? It probably, that you probably have to go to
Yeah.
such extreme measures.
Yeah, and I think that's a great question because, we did that. Our focus was just on, okay, we've got an existing building stock. What happens when in this existing building stock when we have an extreme heat wave? And so none of that answered like, okay, what if we build a brand new passive house apartment building? What is that? How does that do? So that was kind of a question that was kind of lingering in my mind. And the next study we did in-house, Claire McConnell was our building energy modeling. Claire is the actual person doing all the modeling. So I'm really standing on her shoulders and her work and skill to do modeling. I am the fortunate one to get to be a spokesperson about this. So we had a project and it was in the California Bay Area, and in 2022 September there was a giant heat wave that hit there, and the owner of that building has a very vulnerable population that this apartment building was going to be built for, and they're like, should we air condition? And so we're like, let's study it. And they were looking at potentially, and so one of the things we proposed was like, hey, we can make this a passive house project. And so like we figured out what it's, running through, and for me and like Skylar and I think it was Dylan, the two of them created a passive PHPP dashboard, and I use that a ton still, just to sort of as a concept schematic, like how do we make sure we've got it sort of dialed in so that, yeah, it might change every little bit, but it's basically we know it. I have confidence that this is a passive house envelope. And so we did model that. Um, and the thing was, at that point, at that heat wave, also there was a ton of wildfire smoke around, and so it's like that was the question of, okay, well, it's that heat wave was upper 90s, 100, 104 was the peak temperature, and I'm like, okay, well, that's kind of like if we get another heat wave in Seattle, Western Washington, 104 is probably going to be where it is. It's, might not be 108 like it was in the heat dome, but in a place that had only touched 100 like twice in its history, this is a good model. And I also at that point now had balanced heat recovery ventilation in multifamily apartments in the Washington code, and this was a bonus chance to sort of test that. Okay, if we ran,
It's
so
huge. Yeah.
104 degrees outside, what we found out, similar thing, California code, if you couldn't keep the sun out or you couldn't open your windows at night, temperatures should climb up to 120 degrees, which is also in that basically extreme danger quality. In California, the nights were cool enough, but if you were code minimum, you could open your windows. The interior temperature was 94 degrees. And we're like, okay, well, what's the passive house envelope do? And it took it from 94 down to 86 degrees.
That's
So,
huge by itself. I mean, that's massive.
yeah. Yeah. And then we're like, okay, fantastic. We see, passive house in a 104-degree heat wave, no power. You could ride through it and not climb into that extreme caution level above 90.
Yeah.
Okay. Well, there's also wildfire smoke. So let's say you really don't want to open your windows. You don't want to, because you have to make the choice of, do I open my windows at night to cool off a little bit, but let in all this wildfire smoke that's really, really harmful to our health. But with a passive house with heat recovery ventilation, filtered air, you could close those windows, use the HRV system. And so instead of 86 degrees, it was 87 with the HRV running. So it was a really good confirmation that passive house enclosures do work. And I'll emphasize right now that, I say that everything I've been talking about so far applies from, say, the Rocky Mountains west, because it's, we live in our Western U.S. climate doesn't have a lot of humidity. But I think you were bringing up a point, Michael, about there's extremes, and do we design for extremes, or do we design for something sort of like that and sort of keep our fingers crossed? And I think what Passive House is doing for us is, by having that focus be on low loads and an enclosure first, designing to that gives us that buffer or insurance piece. So we don't have to design for the extreme. We're just designing for everyday comfort and health. If we design for that, that gives us a buffer to sort of ride through an extreme piece, without having to spend a lot of extra cost, or saying, well, I want it to stay. We're not trying to keep it below 80. We're saying if it's an extreme heat time and there's no power, we can go through a few days of it being 80 degrees inside. But we don't have to look at our building enclosures and go even more excessive. It's still the fundamentals. Exterior shading works the best. We want to keep the sun from coming in and heating our space, and having ability to have a little bit of, if we've got the ability to cool freely at night, do it. And so I think that's where I think Passive House is helping us, just by designing a passive house. That is giving us more of call it an insurance policy, for better words.
Now let's pivot to Michael's conversation with Kevin Brennan, airtightness and insulation expert at Brennan & Brennan, longtime co-host of Passive House Accelerator Live, and now a member of the Source 2050 team. Kevin shares how he diagnoses what needs to happen first in retrofits.
What do you look, because it sounds like before you even get the passive house, you're looking at other weatherization items first, because it already asks, well, where do you start? But what are you looking at when you're looking at an existing brownstone or an existing freestanding house?
So it's just like as if you were going to your doctor, you'd have a general conversation about, how do you feel? What's your biggest concern? Why are you here today? Start off that conversation about what your plans are for the building and the retrofit. Are there big needs, big problems in the building, the house, moisture? Is it too cold? Is it too hot? And then the next level would be do a blow a door, find out how leaky the building is, and then assess the systems. And then based on what the client's needs are and plans are, then figuring out a solution for each one of those problems. Are you gutting the top floor and you're going to have new roof space? Are you firing it down? Are you removing the front wall from the inside, or is this an exterior renovation? And then just making those plans. Anything you touch, just do it to the best that you can afford and you have the ability, and you want to sequence it right so you don't have to do it twice. That's kind of my advice always. And then stick with the BPI method of test in, test out, and do no harm. So the old school way of doing a blow a door test before and after, checking your combustion appliances to make sure you didn't make the house dangerous, is something that is, should be done. Not mandated by most. It's mandated by most energy efficiency programs, but and then in our projects that we're working on, the brownstones, we're eliminating most of those devices, the domestic hot water heater, the gas appliance, or the furnace, or the boiler. So we are making buildings safer, just in the whole big picture of it. But when you're planning your renovations, just do it smart. You don't want to have a backdrafted hot water heater that leads to somebody getting hurt. But it's weird stuff like that you just got to watch out for.
Next up, Sky, a reimaginer, asks Kara Haggerty Wilson of Onion Flats Architecture about how she navigates uncertainty and guides clients through it. A couple of quick notes. In the clip, you'll hear Kara reference the number 0.06, which refers to FEIS's air tightness threshold, an air permeance of 0.06 cubic feet per minute per square foot of enclosure area at 50 pascals of pressure. Kara also mentions BERDO, which is Boston's Building Emissions Reduction and Disclosure Ordinance.
I was curious also, with so much unknown until you're able to do investigatory demo and like get a more thorough kind of forensic evaluation of the existing, how are you dealing with that, both on the client's understanding of the overall budget and just having to do revisions across the different phases?
Yeah, I'll say that the surprises we found, like when we think of Hano Homes, the project, the smaller project we presented, the surprise wasn't anything we had to like change. It was more something that affected our air sealing, our ability to get as airtight as we wanted. So it didn't make for a change. It just, we had to change our perspective, I guess, on like, what is the solution? We're not going to get to 0.06 for that project. So instead, we're going to get to 0.26, whatever it was, and still be really happy about it. I think there's these projects that we haven't yet encountered something that during construction was like system altering or envelope altering or anything like that. It's been more like, oh, it's they didn't seal XYZ 100 years ago. Of course they didn't. You know, it's taking a small hit here and there and kind of pivoting.
And then that you and the client are aligned on the goals that are less, I guess, quantitative and more like, how are you ensuring that you're meeting the deliverable and expectations on the client end of what they're receiving with this whole process, and that it's worth the value to them?
So some of the clients, the ones in Boston in particular, are up against the BERDO ordinance. And so they're seeking to drastically reduce their energy consumption on site. And a lot of their financing will be tied to like a percentage reduction overall. And the efforts we're putting forth tend to do a lot more than that percentage as a baseline. So we've not yet encountered something that made us think that we weren't going to hit those numbers quite yet. That's not been something that's come up yet. But it is there. Our clients have been really involved throughout the entire processes, and they're on every call. They know every player. They're asking all the right questions all the time, and you know, they're very well educated on it too. So it's not like we have to teach them on it. They already know this stuff, so they're keeping good tabs.
Amazing.
Here, Mary James, Passive House Accelerator's senior editor, asks Kara about striking a balance with standardization in offsite construction.
I want to go back for a minute to the window size being different on different floors. And I just wondered how that affects one of the advantages of offsite construction I had thought was, that you're producing the same thing over and over again. But the panel sizes must have to be adjusted if the window sizes are different on different floors, yes?
So the overall panel width will be whatever they'd like it to be within what they can span, what they can deal with, what they can maneuver. And then, so at Salem, the windows are typically, they're not always in the middle of the panel. It'd be nice if they were. But to your point, it's because the windows are different per floor, it does mean that like the panel window sill height dimension is different per floor too. Yeah, so it's not like a cookie cutter situation. It's a little bit more prioritized for the existing conditions.
Theoretically, I had thought that one of the cost advantages of using a panelized approach was the consistency of the panels that you're producing, that are being manufactured.
Yeah.
But I guess maybe it doesn't matter so much. I mean, because they're all being designed.
They're all being designed. I think here where it helps, like in new construction, that's totally valid that there's cost savings in being able to like get a module and build it 100 times and install it. here, because we're dealing with having to kind of merge with existing conditions, we lose out on that opportunity a little bit, but we still get to have really consistent air sealing details because it's happening offsite. We get QA/QC on the product that's happening offsite. And then, you know, in general, we couldn't build Salem without a panel. We can't physically get somebody to site build that while there's ducts in the way. Like it kind of had to be a panelized solution if we were going to take the systems outboard.
Next is an exchange between Karen, a reimaginer, and Beth Campbell, Education Program Director of Passive House Massachusetts. Beth recently completed interviews with over 40 Passive House builders, designers, tradespeople, and developers in Massachusetts and packaged their collective insights into the excellent report, Cost-Efficient Passive House Delivery, co-authored with Executive Director Alexander Gard-Murray. In their exchange, which includes comments from Michael Ingui as well, Beth dives into the power of the mock-up to influence practice in the field.
Just to briefly summarize where I started with this is I was working on a new construction, 80-unit, 8-story building here in Brooklyn, where they were doing a panelized exterior. I went in advance to New Jersey to look at how they were putting the panels together since I was the energy rater on the job. My job was to do the Energy Star checklists, the thermal checklist, and also to do testing and verification on the any ductwork, which they didn't have, but the apartment airtightness. From the beginning, it looked like they had airtightness handled very well, but with the PTACs, the areas of the PTACs, which I kept warning them about, I was fortunate enough to be on this job early enough to keep reminding them of all of the things to look for airtightness, and especially the PTAC areas. But they were new to this, and this is really actually the basis of my question. So here I am, I'm coming in, I'm looking over their details. So I have to always decide, am I the policeman? Am I the educator? Am I the, how do I get them on board? This really got critical. I mean, in most cases, people do listen to me. We go through examples and things, but when we got to testing the apartments, it was clear that a lot of it hadn't sunk in. And long story short, we went back and forth. It took about 6 or 7 visits to some of the same apartments before they listened to me and took the covers off the PTACs and really took a close look at what had been going on there. So my question—
Karen, just to be clear, so that everybody knows what we're talking about right now, we're talking about the HVAC units that go into the window opening, correct? That do heating and cooling. Yeah. I presume they're heat pumps.
Yes.
Okay.
Yes.
And that you can, everybody here can imagine how you might have air leakage issues because you've got both a window going into that opening as well as the HVAC equipment, which may not be designed to be particularly airtight. And then the installation also matters a lot. Is that correct?
Yes, and the problem was that obviously these PTACs created penetrations in these really nicely, tightly sealed panels.
Mm-hmm.
So the panels themselves were not an issue. The windows themselves were not an issue. It was where they had failed to seal the openings.
And is your question more about like good industry practices for how to seal these, or more so about how do you get people to listen to you as the host trader?
Yeah, because last time you made some very interesting comments about working with the tradespeople. And I usually come in trying to educate them at the beginning and then trying to work with them. There have been times where I have compromised on things that maybe I shouldn't have quite passed on. On a previous project, actually, I got into a back and forth with the architect who didn't understand what was going on.
So I've got two thoughts for you right off the bat, and maybe these are already things that you're talking about. But number one, did you guys do a mock-up first before these were all installed? Yeah. And sometimes it's not in the budget, and sometimes it's really hard to convey the importance of how much money a mock-up can save a project. But especially if the developer's not used to it, whatever, it might not be in the budget. But that's the number one go-to that I'm hearing from teams is like, without a mock-up, we're screwed, you know. And a mock-up doesn't need to be a standalone, because sometimes there's just not budget for that. But especially with an Energy Star project where you've got unit compartmentalization already, so you have some level of airtightness that you're dealing with in your case, you know, using one of those apartment units as a proxy for whole building airtightness can be a really useful tactic. And that might be something that, again, you know, how much leverage do you have as the consultant coming in? Probably it's going to depend a lot on the team, but that's one of the biggest recommendations that I've been hearing is get into that apartment, air test it early. It might mean out of sequence, you know, ordering and procurement for the team, because they've got to, that one unit is going to need to be, you know, if airtight drywall method is your method for compartmentalization air sealing in that apartment, you know, you might have to get some out of sequence trades in there to get that unit done early so that you can test it. But test as early as you can, especially with those PTAC units, it sounds like, because you saw that, you flagged that early, nobody paid attention to you. So I guess my other question for you is around incentive money. Like, is there incentive money on the table for the developer that if they miss Energy Star on this, are they losing a bunch of money on the project? Because that's another way that you can, you know, you've got to talk money. You don't talk the benefits of air sealing or something. And I think you probably already know that, but that's the only way to get people to listen to you is callbacks, making sure that stuff is in subcontractor trades, that who ends up holding the bag if you don't meet these targets. That's if somebody knows that they have financial risk on the line, they're going to listen a lot more. But as a third party, it can be really hard to leverage your power over those subcontracts, over mock-ups, or over those incentives, you know?
Yeah, I would also say, just to echo it, time and money. It is truly amazing to me how quickly the team can do things after the mock-up.
Yeah.
And also, it's always amazing to me because some of the mock-ups we do and some of the stuff we do, I'm so lucky. Very often I've got Kevin Brennan on my job and John Mitchell or Ed May. And we're doing a townhouse and we're doing a mock-up for something I've already done before. Do you know how many times we change how we install it?
Yeah.
It's hilarious. And because it's, you know, that team wants to use this tape or that product or this thing, or, oh, hey, because of the condition of this wall, we want to do one thing. And then they all decide. And then like a couple of days later, everything's installed perfectly, not reinstalled. It's just amazing to me how much time, which in my world is worth more than anything in the universe, and not having to go backwards. The time and then, sorry, risk. I'm right there with you. So yeah, I think the mock-up's a good one.
Well, one thing I'll say is that I usually end up on jobs way after contracts are signed. So even though if you go to my website, you'll see I have a whole page of what I advise developers to do. And one of them is to make sure it's in the contract. If I'm on a job and I find an issue that it's not in anybody's contract, I just back off and I let them work it out before I go forward with the job, which happened on another big job. But the thing in this particular case, there was a junior person in charge of the project at this point who didn't have a lot of authority, and the main contractor was out sick, and so he ended up making a bunch of decisions. He kept wanting to retest things and test them this way and test them that way, and looking in not the places where I was saying. So without coming across as a police person, I've been trying to look for ways to get the ideas across to people earlier so that they listen to me earlier, because I'm usually just an asterisk on the list until we start testing and something fails.
Right. Yeah. And it sounds like you're already doing it. And in this case, sometimes your hands are tied, but it's really that early communication with the developer and showing them, if you can put together even a simple spreadsheet of cost benefit to the developer to have you come in early and have some money in there for mock-up, making sure that doesn't get VE'd out, for example. If you have any anything where you can speak the financial language of the developer, even if, again, if it's a simple spreadsheet showing like, hey, this is my cost to come in early, and this is how much projected savings you're going to have me come in early versus stepping in late and now trying to fix problems. You know, if you can show that in black and white and in translate what you're saying into numbers, even if they're, you know, broad examples of numbers, they don't have to be super accurate. They can be order of magnitude numbers even. That can be a piece to have people's ears perk up, you know. But really what I'm hearing from teams is that paying that extra amount for the consultants to come in early, it pays for itself in almost all cases.
And speaking of influencing and guiding practice in the field, Kevin Brennan has a lot to share. Here, Michael prompts Kevin about the contractor kickoff meeting.
But one of my favorites, which came from you, is the contractor kickoff, where that kickoff meeting with the subs. Just describe the importance of it, and also I'd say, you know, for anybody who's on this call who needs to do one, describe to them how to do one. In your opinion, to do it well.
My inspiration for it was just getting everyone on the same page and setting the standard of the project. So coming from the GC, the architect, and the owners, that everyone working on the project needs to know the rules of the game. You know, like, it's a different type of project. It's not standard construction. You can't just make a hole anywhere you want. You need to ask permission, and is this okay? And I kind of mimic that training based, not like opportunity or kind of like introduction to the team. This way we set the hierarchy, right? The GC's in charge, the architects over construction administration's overseeing everyone. And then who are the key players on the project? The plumber, the electrician, the insulator, the carpenter, just making sure they all work well together and explaining what the goals of the project are. And this way, even though you're an electrician, you're like, I don't touch outside walls, or, you know, like I'm just an electrician. And it's like, but you can't, I wouldn't ruin your work. Don't ruin my work. In that I wouldn't put holes. I wouldn't cut your electrical wires and not tell you, please don't do that to my air barrier or my insulation. And I mimic the training based kind of like on like a safety training, like a safety orientation of like, this is the project, these are the rules, this is what it is. And then a little bit of show and tell, kind of like, these are the products we're going to use. This is how you air seal. Not easy, right? It takes some time. I have to clean. And it's just creating that level of respect on the project for our work, which is semi-new, to old work, which is standard, and then how they all interweave. And then in the trades, kinesthetic learners, they like to look, listen, and feel and touch. And I love leaving mock-ups or kind of like drawings or ways of instructing that then stay on the site. And then when you get new people on the site, they can be like, this is what this needs to look like. This is different. This is a passive house. My favorite anecdote information was working at one of the early projects, and it was the middle of the winter, and there was no heat on whatsoever, no temporary heat, and the painters were showing up, and they were like putting shorts on, and they would put their winter clothes on to go home, but all day they were working, painting in their shorts, you know, in a quiet building. The air was good, it was filled with light, and it's like, this is different, you know. All our other projects, we're freezing. And
it is pretty wild. And not only that, but everything, the paint was dry, and everything about it was better. So you just brought up something that dawned on me, because I'm actually dealing with a situation right now where mock-ups are important, direction is important, and I feel like it's not my project per se, but I'm working on a project where there is a little bit of time being wasted or spent just waiting for mock-ups and direction. And one of the things that I guess I took for granted and still do is that part of our, when we do these initial meetings with the contractor, we've typically already met with the passive house consultant and you and others, and we know what our makeup is of our wall and our window, and part of what they're learning on is that makeup. So maybe talk about the importance of a mock-up, because I think for some of them, I'm remembering some of our projects where you didn't know if you're going to use peel and stick, or you didn't know if you're going to use tape or some liquid applied to, you know, what's your recommendation there?
Early, and then navigate what the library is, or what potential products you can use, and narrow that down. It can be very overwhelming for a general contractor that's not an air barrier specialist to look at all the air barrier products and be like, this is the one I want. Because it's intimidating. You kind of do what you have access to, like, what does my local lumber yard sell? What have I used before? Have I purchased it before? Those kind of guide a lot of the GC decisions, logistics and purchasing, and then figuring out what they are. On my projects that I worked on, me being the tester, so I knew I was going to test early. I tested my own stuff. If this is your project or do an early mock-up and test it. So build a chamber onto it. I've been pitching for years. No one's ever done it before. But the office, the PH with the office, whereas every construction site needs a place to take a phone call in a meeting that is quiet, dust-free, and depending on what products you're using, you kind of need them to be weather safe and that they don't freeze or dry. So build a small little corner of one project with one window, build 3 walls onto it, maybe a ceiling, use the floor, whatever it is. Put it up. That's your first run mock-up. It's a place where you'll keep everything. You test it. You know it's tight. If everything else looks like this, we'll be in good shape. But you're testing like 5 different things at once. You're testing the window to the wall airtight connection. You're testing your fluid applied air barrier on the block. You're testing your through floor in connections. And then you can take it to the next level and have it be like a finished mock-up. People, clients, architects, GCs, they like to know what something is going to look like in the future, and it kind of like builds on confidence. But making the blow a door or testing ability, you don't need to send it to a laboratory and have it tested. You get your first window early, plus everyone likes to know, like, was it easy to get? Was it easy to bring in? Like, is this a sample? Like, can you logistically get me 1 window in 4 weeks? Because if you can't get me 1 window in 4 weeks, how are you going to get me 20 in 20 weeks?
Next, we hear from Nakita Reed and her Reimagine Design interview with Michael. Nakita is Associate Principal at Quinn Evans and host of the podcast Tangible Remnants. Here, Michael asks her how she integrates architecture, preservation, and high-performance building design, priorities that are sometimes viewed as working at cross purposes. Incorrectly viewed, Nakita will point out.
How do you deal with that? And you've got 2 loves, or I guess 3: architecture, preservation, which you might join into 1, and then high performance. And you're constantly kind of marrying the 3, I guess.
Yeah, and a lot of it is a lot of conversations. And so I know there are some times that some architects, they view like the State Historic Preservation Officer or the various regulatory bodies as adversaries as opposed to collaborators and partners. So on all of our projects, I'm often making sure that we are having these conversations early and often with the various approval entities to let them know this is what we're planning, here's what we would like to do, where are there gaps, where it's potential, what could potentially be a holdup or that sort of thing. And so a lot of times when we're able to not only help communicate what we want to do, but also help educate the different policy makers and even the regulatory agencies on what we're trying to do, that helps because I found that, surprise, surprise, many of the people enforcing policy aren't as familiar with the realities that we're facing in the day-to-day. And so being able to bring them along during the process before they just have to be like, all right, I have 10 days to approve or deny this. I'm not familiar with what this is, denied. Come back with more information, that sort of thing. So having those types of conversations early and often, and also just developing the rapport with them so that they're familiar. Like the permit official in Baltimore knows me, the SHPO knows me. So it's one of those things where being able to have those conversations helps build that relationship and that trust. So they also know that I'm not trying to get over on them. I'm not trying to skirt the intent of the code or the law or the standard, but really trying to be creative and solve these problems.
In this clip, we hear Nakita share her advice to architects who are beginning their first historic project.
It's also funny because the number of architects who will come to me after they have taken on a historic preservation project, only to realize that, oh, there's more, there's actual laws and standards they have to follow on this project. Yeah, it's not a hobby. Like, all right, well, what did you get into? How can I help you unravel this and the approvals you need to do? Because I think that's the other thing where a lot of times people get very upset or they feel like preservation is very hard or adaptive reuse is so difficult, but really it's just they're not familiar with the system and the approvals, and so they do things in the
Mhm.
wrong order, and that holds up a bunch of things.
Oh,
Yeah,
sequencing.
yeah, so
I will
important.
say on historic preservation, it wasn't going to be one of my questions, but now it is. Because you're right, sequencing.
Yeah,
It becomes that much more important when it's a historic
yeah.
restoration, first of all.
Mhm.
But if you're dealing with a certifying body, when you're dealing with preservation, even that much more important. So maybe
Right.
talk a little bit about that.
Yes. And part of it also is just knowing where to check to prevent some of the pitfalls. And I know most of you are architects on the call, so the biggest nugget I'll give you if you're working on a historic building is to double check to see if there's an easement on the property before you start doing anything. And one of the horror stories that I heard when I was first starting out in my career was that there was an architect who was really well known, and she decided to do some work for historically Black church in the Eastern Shore of Maryland. And she was like, oh, they have this great big parcel of land right next to their building. They could do a fantastic addition. The church was like, this sounds great. We want to do the addition. Yes, please design this and let's go. She designs it. She submits it to the building permit office to be able to get a building permit. And they say, you can't build anything on this plot of land because there is a historic easement on this property. That
Mhm.
the church leadership at some point in time, decades previously, gave the SHPO a perpetual easement saying they would never build on this land because they were going to get however much money from the SHPO for a grant or something like that. And
Mhm.
so she had to go back to the church and say, I'm sorry, you can't build here because you have this easement, but you also owe me tens of thousands of dollars because I already did this work. And so
Yeah.
it's like that friction between, I know you can't do what you wanted to do, but I did the work from a design standpoint. So now you owe me money. But then it's like, well, how are we going to pay you if we can't raise money for capital improvements we can't do? So it's just kind of like that
Catch
friction.
22. Yeah,
Yeah,
yeah.
exactly. And
It's a
so
toughie.
And here, Reimaginer Ranger Pinney asks Nakita about how she advocates for energy efficiency within the context of historic preservation work.
I'm sure that you sometimes will get some pushback, and it feels like you're in a really unique position of being an advocate for both high performance and preservation. And I'm sure that there are choices,
Mhm.
that hard choices that need to be made sometimes. And there's some preservation purists that I'm sure would be really resistant to changing envelope details and having to build up walls from either the inside or the outside. And just kind of curious what your pitch for energy efficiency is in some of these buildings.
Yeah. Yeah, that's such a great question because you're right. There are some preservationists who don't buy the idea that sustainability and preservation go hand in hand. Same way there are some sustainability folks who don't buy it from a preservation side either. So it's interesting because there are some people who really care about, well, what's the mortar on the building? I just want the mortar to be repaired and that's all I care about. But from a broader preservation standpoint, being good stewards of buildings means keeping people in the buildings and keeping people caring about the buildings. Because once a building is no longer cared for or upkept, that's when all of the bad things start to happen because people stop doing repairs, the roof starts to leak, water gets in, it's not secure anymore, vandalism starts to happen, and then it becomes a place that if no one cares about, then it's going to fall apart. And so being able to keep people comfortable in a building is a great way to be a good steward for the building, which is going to, in the long run, keep the building preserved and cared forward. And so oftentimes when I am talking to, I lovingly call my preservation purist nerds. And I'm one of them sometimes. I'm just like, all right, I get it. All right, nerds. So this is what we're going to do. Like it's very much we need to actually think holistically about the building, because otherwise we're going to miss the forest from the trees. And so it's funny because I'm just a total nerd because both my preservation folks and also my passive house folks, like, it's like, hey nerds, what's going on? Like we're very much nerdy on all of this. So it's like, are we talking about building science? Are we talking about the mortar? Are we talking about what kind of plaster is it? So it's just being able to find the different things to nerd out and being able to find the different things that people care about and are passionate about to be able to get them to be open to that conversation is a lot of talking.
By the way, I think you just hit a bit of a sweet spot in that conversation, though, because I think, and it reminds me so often of the Oris group's talk at one point. We're starting at the end. They were talking about it from mechanical perspective, but I think it also works in this one where you're talking about a use perspective. And yeah, if the end users, if it doesn't have an end user, we're doomed. There's only so many truly beautifully historically preserved buildings that don't have a real use because they're uncomfortable or aren't set up well, or the rooms aren't the way people work or live anymore. That we need. I mean, we need a few of them maybe, but you really in my mind, I wrote it down. That's a sweet spot right there. That's the place to start the conversation.
Right.
If you don't do this, and the building becomes less useful, all of a sudden this building's in danger, forgetting all about historic preservation.
Right, exactly.
In our last clip for today's episode, we hear from Beth Campbell again. Now, in case you didn't know, an incredibly exciting boom in passive house is underway in Massachusetts, spurred on by a policy framework of incentives and code. Beth shares the numbers they're seeing right now.
So within this massive pipeline that we have going on in Massachusetts right now, we have just an enormous number of projects that are in the works. So we've got around 2,000 certified units. So most of these are apartment units. Some of them are single family homes, but mainly multifamily. We've got 5,000 that have been design certified. So those are well into the pipeline. We've got another 8,000 registered units, meaning that, this is money that people have paid to get these projects registered. So we feel pretty confident that they're in design now. And then there's another 21,000 that have been kind of preliminarily reviewed. So over 30,000 units of primarily multifamily passive house projects that are in the pipeline right now that aim to get certified. And essentially we've got about a third of the population of Massachusetts has opted in to these specialized codes areas that require passive house certification for certificate of occupancy, essentially. So we've got a lot coming down the pipeline. So that's why Massachusetts is so focused and making sure we've got a lot of really great opportunities out there for folks to get certified as CPHCs or Ds, or take builder or tradesperson certification courses. There's going to be a lot of people that don't take those full certifications that still need education. And so that's where our target focus is.
I had the honor of visiting Boston a couple weeks ago to deliver the keynote address at Passive House Massachusetts 2025 Passive House Symposium. During my visit there, I learned that Beth's numbers have been updated to 35,000 units being in the pipeline now. If all were built, that would amount to somewhere between 30 and 35 million square feet of passive house and passive building projects in just one state. For context, the entire U.S. has about 12 million square feet of certified passive projects built to date. So Massachusetts is creating a hockey stick of adoption of passive house for the entire country. Incredibly exciting. On that note, I hope these snippets of our experts and residents in the collective have piqued your interest. You can dive into the full replays of these conversations, all available in the collective. And if you're not yet a member of the collective, we'd love to have you join us. You'll get direct access to experts and peers who are on the same journey with buildings, resilience, and climate. Learn more at reimaginebuildings.com. Speaking of members, a warm welcome to our newest reimaginers. Kristen Bailey, Scott Drennan, Aaron Sauerhoff, Carrie Beer, Liam Smedley, Kevin Stack, Laura Blau, Benoit Menu, Gio Beltran, Mark Grannon, Jennen Pertzlinger, Joseph Martin, Susan Bloomquist, Rebecca Griffith, Tamia Sakosi, Jane Sanders, Matthew Richardson, Peter Rager, and Jake Bales. With that, thanks for listening to this 14th episode of the Reimagine Edit, a production of the Passive House podcast by Passive House Accelerator. It's a privilege to bring these conversations from the Reimagine Buildings Collective into the open. Each time we share what we're learning and take the time to really listen, we sharpen our practice together. None of this work happens in isolation. We're learning alongside one another, building as we go, and gradually finding clearer footing toward the future we're trying to create. So thanks for being part of this ongoing experiment in reimagining buildings. And if you're not yet part of the collective and you're curious, check it out. We'd love for you to join us. With that, have a great couple of weeks. We'll be back soon with another episode of the Reimagine Edit.